reflections. So we're still talking about transformations of figures. We're going to focus on a reflection now. So a reflection, or a flip, you've probably heard of flips before. A flip is a transformation in which a figure is reflected in a line called the line of reflection. A reflection creates a mirror image of the original. So if we think about looking at something in the mirror, everything is in the same similar position, same size, same shape, it's just kind of reversed, if we think about it that way, or flipped. And that line of reflection is kind of in the middle, in the middle. So everything's the same distance from that line of reflection, just on the other side. Tell whether the blue figure is a reflection of the red figure. So we've got two figures here. I've got two half moons along this line of reflection. And if I think about how they are related to each other, yes, this blue figure is a reflection. They're about the same. They're the same distance from the line of reflection. I've just taken one and moved it and flipped it over that line of reflection. Let's take a look at another example here. So I have my figure on top, my figure on bottom. This is not a reflection because as I look at this, I have not kind of changed the position of these points here so that they are reflected or flipped over the line of reflection. I should have that the smiley part is closer to the line of reflection than the eyes. That's not the case here. So they all should be kind of related to that line of reflection in the same way on both sides. Let's do some reflections ourselves. So again, we can talk about reflecting two ways on a coordinate plane. We can talk about reflecting over the x-axis. We can also talk about reflecting over the y-axis. So to reflect a figure in the x-axis, take the opposite of the y-coordinate. So since we're taking this figure and we're moving it up and down, what is changing is the up and down coordinate of that point, which is the coordinate on the y-axis. So we can keep the ordered pair, just find the opposite of the y-coordinate. The vertices of a parallelogram are A is -1, -1, B 2, -1, C 4, -3, and D 1, -3. Draw the figure and its reflection in the x-axis. What are the coordinates of the image? Remember, the image is our new figure. So if I draw my first figure, here's my first figure of my parallelogram. I drew that out. If I think about a reflection, I am going to move everything the same distance from the x-axis. We're reflecting over the x-axis. It's going to be the same distance over the x-axis, just on the other side of my axis, so the other side of the coordinate plane here. So my A is 1 unit away from the x-axis. It's still going to be 1 unit away from the x-axis, just above the x-axis. B is 1 unit away from the x-axis. It will still be 1 unit above. It's going to be the same as far as the x-axis left to right. So if I just wanted to look at the coordinates, I could go back and remember that I'm only changing the y value here because I'm just moving it up and down on the y-axis here. So I can take each of my ordered pairs and simply take the opposite of the y value. So -1, -1 becomes -1, 1. 2, -1 is 2, 1. 4, -3 is 4, 3. And 1, -3 is 1, 3. And those line up with the points that we got when we just flipped it without thinking about the ordered pairs. My A is -1, 1. My B is 2, 1. My C is 4, so this one goes farther out, 4, 3. And my D is 1, 3. So that's a flip or a reflection over the x-axis. Now let's talk about a reflection over the y-axis. To reflect a figure in the y-axis, take the opposite of the x-coordinate. So since we're reflecting this over the y-axis, we're talking about a change along the x-axis. So the x value, the x-coordinate, is going to change, and we can simply take the opposite. It's going the same distance, just in the other direction. So if I have the vertices of a triangle are A, 1, -2, B, 4, -2, and C, 1, 4. Draw the figure and its reflection on the y-axis. So we're going to reflect that over the y-axis. So here are my original points. I'm going to find the opposite of the x-coordinate since I'm reflecting it over the y-axis. So I'm going to take all of these x values and find their opposites. So I come up with these ordered pairs. A is -1, -2. B is -4, -2. Notice the y value is still staying the same. And C is -1, +4. When I graph these two, here's the original on the right-hand side of my y-axis, and I notice that my image, my new figure, is flipped over the y-axis, and it's on the left of the coordinate plane. Notice I've labeled each of these with my primes, so this is A prime, B prime, and C prime.